So hello, welcome back to another geology video, and in today's video we're just going to have a quick look at the different forms that magma takes when it's underground. So basically these can form volcanic mountain ranges, so volcanoes, which is up the top, but most likely is that a lot of this material is just going to be underground for majority of the time until erosion removes the upper layers or anything that's protecting it and exposes it at the surface. So the first thing we need is a batholith. So this is the large pool of magma that forms. So magma is the solidification of this, so when the material is cooled. So you've got magma chamber with lots of heated magma over 700 degrees, depending on the water content, but we're not going to go into that here. So this cools and crystallizes, forming a large batholith. So that's the granite, diorite, etc. provinces that you see after the material on the top has been exhumed or removed. So what we have here, so this will be a dike. So a dike is a smaller intrusion that's gone through a fracture in the rock. The larger, so here we have a volcanic neck. And that is a much larger, supposedly a much larger dike. Usually is a lot wider. The wideness, well, it depends on who you're going to follow, but it needs to allow large volumes of magma to upwell to the volcanic caldera or whatever type of volcano is present. Also, the type of material would depend on what's happening in here. Crystal fractionization could change it from probably a basaltic type material to a granitic, and it also depends if this batholith comes from the mantle or it is just melted crust. So there is differences. We're not going to talk about that here. Okay, so when it upwells, and sometimes it might meet some type of obstruction, but the material underneath is, there might be a fault, fracture, or even partial melting here, and it pulls underneath in the ground longwise. This causes a sill. Now, two things that are similar to a sill are lopolith, laccolith, and pictolith. So a laccolith forms when it pushes it would pull on top of one formation and it pushes the rest of the formations up. A lopolith pulls also on the bottom of the formation and pushes the material down. A pictolith, and these form in relatively flat bedding planes. If it's faulted and folded, so you got a anticline and a syncline, but the material pulls either at the top or bottom of those, then you have a pictolith. So that is what a pictolith is. And I would say it's less likely that the material could probably pull underneath here and up here, because the material that's forming this fault, sedimentary, where obviously this is a sedimentary rock because it has layering, then it's probably less likely, because this is, unless it's been faulted or it's been cracked, then this is quite solid. So it's more likely that this is caused by the material being pushed up by the pictolith, and this has been caused by, obviously, this material will be pushed up and this will be pushed down. There's many different mechanisms, and I don't believe a lot of them are actually, so a lot of them depending on the author, which is the actual way it works. So this is just simplified. It does get a lot more complicated, which is beyond my knowledge for now. Anyway, I'd like to say thank you very much. Hope this helps you with your magmatic intrusions.